Today, we're diving into a project called LogicDS. It's all about bringing cutting-edge tech education to students everywhere, no matter their zip code. So let's get right into it and see how they're pulling this off.
So let's start with a really thought-provoking question. Think about this. What if your whole future in tech came down to where you live? I mean, it sounds unfair, right? But for way too many students, that's exactly the reality. The opportunities you get in, cool fields like data science and AI, it can totally depend on what your local school can afford.
And that right there, that's the heart of the problem. We've got this growing gap. For a lot of students, especially in rural communities, these advanced STEM courses are just, well, they're out of reach. And it's not just that the topics are hard. It's that their schools might not have the teachers with that super specialized knowledge.
Okay, so that's a challenge. But here's the good news. There's this really ambitious project called LogicDS, and they're tackling this problem head-on. And their secret weapon? Virtual learning.
And listen, this isn't just some small side project. We're talking about a major collaboration here. You've got heavy hitters like Texas Tech and the University of Florida, plus a whole team of research and evaluation partners all working together. And they've got some serious backing to make it happen. Get this, a $2 million grant from the National Science Foundation. That's a huge vote of confidence, giving them 4 years to really develop and test out this whole new approach. Okay, so what is their secret sauce? What's the magic here? What makes this LogicDS curriculum so different and, from what we're hearing, so effective?
It really comes down to this idea of a unified framework. See, instead of throwing computing, math, and statistics at students as 3 separate, kind of scary subjects, LogicDS uses mathematical logic as the common thread that ties them all together. It's brilliant, really. It lowers what's called the cognitive load, which is just a fancy way of saying students don't have to juggle a ton of different, unrelated ideas at the same time.
And here's how they do it, which is so smart. First, students learn the concepts using what's called a universal language. It's designed to be totally intuitive, right? The way a human would think. So if you add the vectors 1, 2, and 1, 1, you get 2, 3. Makes perfect sense. Then, once they've got the idea down, they switch over to Python. Now, Python has to follow strict rules for the computer, so that same operation actually sticks the 2 lists together to make 1, 2, 1, 1. By learning the why before the how, it makes the whole process of coding way, way less intimidating.
Okay, so let's walk through an example to see how this actually works. How do you go from a big idea to something you can actually use? Let's take a look at a problem from one of their lessons.
So, it all begins with a story. Super simple, totally relatable. No scary formulas, no abstract math. Just a real-world situation anyone can wrap their head around. Then the next step is to take that story and organize it. The students themselves put the information into a simple table. And right away, you can start to see a pattern, right? You can see the clear connection between the hours Peter works and the money he makes.
And this is where the magic happens. Once the story is turned into data, the math behind it just appears. It becomes obvious. That formula, which might have looked abstract on its own, is now just a super simple way of describing Peter's day at work. It's not scary anymore. It's just a tool.
All right, so once students nail these basics, the course levels up. They start tackling more complex stuff, the kind of real-world data science problems they might actually face in a job someday. But Peter's income is a perfect straight line. What happens when the data isn't so neat and tidy? What do you do with messy, real-world data, which, let's be honest, is pretty much all data?
Well, they give them real data to play with. For example, check this out. A table with roller coaster heights and their top speeds. Now, you'd think a taller coaster is a faster coaster, and you're generally right. But it's not a perfect straight line. There's a trend, but it's messy.
And this is where they introduce a really powerful tool called the line of best fit. Basically, it's a way to draw one single straight line through all those messy data points that best represents the overall trend. And once you have that line, you can start making some pretty good predictions, even when your data isn't perfect.
Okay, so we've seen the method, we've seen the tools. What does this all add up to? What's the actual real-world impact of teaching this way?
Well, the results they're seeing so far are fantastic. The research is showing that this logic-based approach really works. It gets students from all kinds of different backgrounds engaged. And maybe even more important, the students get it. They see how valuable these skills are for their own futures. Plus, the whole virtual setup is a huge win for schools that are stretched thin on resources.
And that really brings us to the big takeaway here.
The success of LogicDS just goes to show what's possible when we get creative and rethink how we teach these complex, crucial subjects. It really makes you wonder, doesn't it? How many future innovators, how much incredible talent is out there right now just waiting for a chance like this? What could we unlock if we could just close that education gap?